Okay, now we're ready for section 8.4, which is about volume and surface area. So here are some regular shapes we need to get to know. This is called a rectangular solid, and it is more commonly known as a box. So a rectangular solid that has the same length, width, and height is called a cube. And so this is called a cube. And a circular shape like this is called a cylinder. All right. And so these are some basic shapes we're going to be talking about. We're going to look at their volume and also their surface area. Other basic shapes that you need to be aware of is a cone. I think of this as like, this is the same thing as if you've ever gotten an icy, or a snow cone, if you ever gotten a snow cone, those little white paper cups, that's exactly what this is. You can fill that up with your snow cone. And this is a sphere, so it's a ball. There's an inside part to this. So these are three-dimensional figures. They have length, a width, a height, so to speak. So this would be the length, and this would be the width, and this would be the height. So when we're talking about volume, what do we mean by that? We mean how much can it hold? So if you think of this kind of like as a fish tank, how much water can this hold? That's what we're interested in. Or how much space is in this box that you could pack stuff in? How much soup could you put in a cylinder? Or how much grains of feed could you put in a cylinder? Or water could you hold in that tank right there? That's what volume has to do with. Surface area has to do with like the amount on the outside. Like if you were going to wrap this box in paper, how much paper would it take to wrap that up? So we're concerned with how much length the outside area is on this. So you know, a cube, you can't really see all this, but I'm going to draw on kind of the back part to this. There's like 6 faces to this cube, so you'd have to have a piece for this, for all 6 faces. So that's what you're worried about, is how much coverage is right there. So that's what they mean by surface area. So let me pause this for just a second. Okay, so the volume for a rectangular solid is simply the length times the width times the height. And so for a cube where everything is the same side, the volume would be length times width times height, or x times x times x, or x cubed. And for a cylinder, it's the area of the top, which is a circle. So if this is the radius, the area of the top, which is pi r squared, times the height, times the height, times the height. And this is the volume of the cylinder, pi r squared times the height. And for a cone, the volume is 1/3 pi r squared h, which is similar. It's the same as for a cylinder, only it's 1/3. And the volume of a sphere or a ball is 4/3 pi r cubed. Okay, that's the formula for that. Also, there's formula for surface areas, and that's what these are. For a cone, it's pi r squared plus pi times r times the square root of the radius squared plus the height squared. And the surface area of a sphere is going to be 4 times pi times the radius squared. What about the surface area for the rectangular solid? Well, if we think about a box, which is easy to, here is a box of tissues, okay? It's got this, there's 6 sides, okay? So if I look at this side, there's the top and the bottom, so I need 2 of this times this. So 2 times the top and the bottom, which is going to have, if you look at that, if I look at this, it's going to be length times width, and this is the same, length times width. So 2 times length times width, this is the surface area, plus this side and this side over here, this side and this side, so 2 times width times height, plus the front and the back. And the front's going to be length times height, 2 times the length times the height, and then that other side, length times the height. So this is the formula for surface area for a rectangular solid. And for a cube, the area of one face of this cube is just going to be x squared. And there's 6 of them, so it's 6 times that would be the surface area. Now, the surface area for a cylinder, it's kind of fun to think about. If you look at a cylinder, I got this can out of the cupboard to illustrate this cylinder for you. The top is a circle and the bottom is the circle. So we have 2 of those. So 2 circles is 2 pi r squared. Plus, we have all of this stuff in here. So if you were to take this can, if this metal can, and I were to cut it and open it up, I'm going to show you what it would look like by showing you what it looks like with the label. So if I take the label, is it going to work? I'm going to kind of try to take the label off. It's almost going to work. If I take the label off and lay it out, it is going to be a rectangle. If it hadn't ripped, you could see the rectangle. So if I took the metal can and unrolled it, it's going to be a rectangle. And so the height is this height right here. So you have this rectangle of cut metal. And the height is this height right here. And how much it unrolled is this, how far around the circle is, which is the circumference. So this part of the rectangle is 2 pi r. So this is how they get the formula for the surface area. The area of the top plus the area of the bottom plus the area of the middle, which is this rectangle, 2 pi r h. And this is the area for surface area for a cylinder. All right, so those are the basic shapes and the basic formulas. Now we're going to do a quick problem. Determine the volume and surface area for each of the following 3-dimensional figures. Use the pi button on your calculator and round your answers to the nearest hundredth. So this is a rectangular solid, so the volume is equal to length times width times height, so 23 times 11 times 5. If I multiply all those together, I get 1,265, and that's cubic millimeters. Now the surface area is going to come from adding up the front and the back. So the front and the back is this part, and the back is going to be 23 times 11. So 2 times 23 times 11 plus this side and that side is going to be 5 times 11, 2 times 5 times 11 plus the top and the bottom, 2 times 23 by 5. 23 by 5. And when I multiply those together and add them up, I get 846 millimeters square. So, what happens there, I want you to take notice that volume is in terms of cubic something and area is in terms of square something. All right, cool. For this cylinder, the volume is equal to pi r squared h. The radius is 7, so it's 7 squared, and the height is 15. So when I put that in my calculator, 7 squared is 49 times 15 times pi. I'm going to get 2,309.07 cubic inches. And then the surface area is going to be 2 times pi times the radius squared, 7 squared, plus 2 times pi times the radius, 7, times the height, 15. And so when I plug all that in and add it all up, I get that the surface area is equal to 967.61 square inches. All right, the volume of a cone is 1/3 pi r squared h. 1/3 pi, r is 7, r squared, h is 15. And when I put that in my calculator, I get it to be 769.69 cubic inches. And then the surface area, I can just use this surface area formula right here, is going to be pi r squared plus pi times r times the square root of r squared plus the height squared. And so when I do this in my calculator, I would do order of operations. I would say 7 squared, 49, plus 15 squared, and then I would take the square root of that and multiply by 7 and multiply by pi. And then I would add it to all of this after I got this, which is 49 pi. And when you do that correctly, you will get 1017.88. No. I got that wrong. I got you the wrong number. When you do this correctly, you will get 517.96 square inches. All right, this is a sphere with a radius of 9. So the volume for a sphere is 4/3 pi r cubed. And you're going to end up with 3,053.63 cubic centimeters. And the surface area is 4 pi r squared. So when you put that in your calculator, 4 pi 9 squared, you get 1017.88 square centimeters. So that's what you get there. All right, last example for this video. Maya needs to replace the sand in a rectangular sand volleyball court. The court is 60 by 30 wide, and the sand has a uniform depth of 18 inches. Sand sells for $27 per cubic yard. So we need to figure out how many cubic yards she's got to get. So here's one thing I noticed is that this is in inches and these are in feet. So I'm going to convert 18 inches to feet. So I know that there are 12 inches in 1 foot. So I'm going to do the conversion. I'm going to multiply this by 1 foot over 12 inches because I want to turn into feet. So I put that in the numerator, and these cancel just like they divided each other out. So 18 divided by 12 gives me 1.5 feet. So this is really 1.5 feet. Now we're all in the same unit. So the volume of this rectangular solid or area is going to be length times width times height. And so the volume is going to be equal to 2,700 cubic feet. Now, she wants to put sand in it, and sand costs $27 per cubic yard. So I want to figure out how many cubic yards this is. So what I need to do is this. I need to say there is 3 feet in 1 yard, right? So if I cube both sides of this equation, that is legal. So 3 to the 3rd power is 3 times 3 times 3, which is 27. And feet times feet times feet is foot cubed. 1 cubed is 1. Yard cubed is yard cubed. So this is a new conversion that I have. So if I need to change this to cubic yards, I'm going to multiply this by, I want the yards in the numerator because that's what I want it to turn into. And I'm going to divide it by the 27 cubic feet. These will cancel. And when I take 2,700 divided by 27, I get 100 cubic yards. That's how much she needs. That's how much sand. Well, if it sells for $27 per cubic yard, $27 for every cubic yard, and I need 100 cubic yards, then it's going to cost her $2,700 to get the amount of sand she needs for that.